everyone. Congratulations. Last section of the chapter before the test, section 3.3, measures of position. Very easy section compared to the last section. Psalms 34:8. Oh, taste and see the Lord is good. Blessed is the man that trusted in him. Barbara Bush said, never lose sight of the fact that the most important yardstick of your success will be how you treat other people, your family, friends, and co-workers, and even strangers you meet along the way. Very important. Question answer, why do you rarely find mathematicians spending time at the beach? This is funny. Because they have sine and cosine to receive a tan and don't need the sun. Hopefully you understand that riddle. So I thought you might enjoy that to lighten things up just a little bit. I want to remind you to make sure you know the empirical rule versus Chebyshev's theorem in the last section. A picture of empirical rule I'm going to put on the document camera now, just so you get an idea of what that looks like as a visual. Again, if you have problems with the calculator, come and see me. There's Chebyshev's. Sorry about that, the mic. Sorry about that. And then here at the bottom, let me see if I can put that on the document camera. At the bottom of page 144 is the empirical. You can see one standard deviation is 68%, two standard deviations is 95%, and then we promise 99.7% of the data values to fall within 3 standard deviations of the mean if the data set is said to be normal or symmetrical. So the empirical rule only applies to a very special type of distribution called normal, bell-shaped, or symmetrical, okay? So make sure you know the difference between those. Now, last section. Before we actually go to the last section, if you need review, there's another worksheet that has been posted under the worksheet button. I'm asking you a definition or two, and then for this grouped situation, you could actually find your mean, median, mode, mid-range, range, and variance and standard deviation. I think that would be excellent practice, is to be able to put this grouped problem in your calculator. You would need a midpoint column, and then you have your frequency column, and it's that simple. So if you can find your midpoint column, your midpoints go in the L1 column, and your frequencies go in the L2 column. And of course, you can do this by hand. You would need a cumulative frequency column, an F times midpoint column, and an F times midpoint squared column. I do have the answers to that particular worksheet, but I just want you to see what kind of columns would need to be constructed if you're going to calculate the mean, median, mode, mid-range, range, variance, and standard deviation by hand. Very, very important. One more time, the cumulative frequency column is needed for the median. You are going to see today with measurements of position that you also need the cumulative frequency column for measurements of position. So you have to have it. Okay, measures of position are items like z-scores, percentiles, deciles, quartiles, and percentiles. These are the lecture notes that are posted under the lecture note button. We're going to talk about z-scores and percentiles first, because deciles and quartiles are percentiles. The definition, all of these measurements of positions are used to locate the relative position of a data value x within its data set. And the data value should always be put in increasing order before you find the measure of position. A z-score, every data value x in a data set can be represented by its z-score. And the way to do that is to use the formula. The data value in the data set minus the sample mean of the data set divided by the standard deviation of the data set. And this is if you're dealing with a sample versus a population. And by now you should know the difference between a statistic and a parameter. The z-score for a data value x tells us the number of standard deviations that the data value x falls above or below the mean. Very, very important to know the concept of z-scores, particularly in Chapter 6. So, here's an example. Which has a better relative position? A score of 43 on a stats test that had a mean of 40 and a standard deviation of 3. Score 75 on an accounting test with a mean of 72 and a standard deviation of 5. You may want to say 75 because it's a better grade, but again, we don't know the background for each class. We don't know the testing situation in each class. We just know the score of a student, the mean of the class, and the standard deviation of the class. So statistics test. The z-score for this particular student with a 43 turns out to be 1. That means this student's score is 1 whole standard deviation above the class average. That's pretty good. This student of 75 has a z-score of 3/5, not even an entire standard deviation. It is positive, so that means the 75 is only 3/5 of a standard deviation above the mean. So the grade of 43 actually has the better relative position, since that grade is 1 entire standard deviation above the mean. So it's actually better, believe it or not, even though it's a 43. So z-scores can be positive, greater than 0. That means that the data value falls above the mean. It can be negative, less than 0. That means it could fall below the mean. And then if a z-score is ever equal to 0 for a data value x, that means that the data value x is exactly equal to the mean. Now, percentiles. The percentile level or rank of a data member x is a number p such that p% of all the members in its data set fall below it in the distribution. That's very, very wordy, so I take an example. Suppose you take an end-of-course exam in calculus, calculus 1, calculus 2, or statistics. Your raw score in that class is an 80. But we tell you that your percentile rank, or that your score falls at the 60th percentile. What does that mean? 60% of your classmates' score fall below your score of 80, and 40% of your classmates' score fall above your score of 80. So you did better than 60% of your classmates, but 40% of your classmates did better than you. So that's what it means by having a score that falls at the 60th percentile. So 60% below your 80, 40% above your 80. And here's notation. P sub 60 equals 80 means that the data value located at the 60th percentile is the score of 80. Percentiles divide a data set into 100 equal parts, so there's 99 percentiles. And I have that division here, P1 all the way to P99, and each little subdivision is 1%, and they all add up to be 100%. So if a data value x falls at the 5th percentile, which is here, 5% of the other data values in the set fall below it, and 95% of the data values in the set fall above it. Okay? So 5% below, 95% above. Okay? Percentile rank for a data value x. If you know a data value and you want to find its percentile rank, it's the number of values below it. You have to put your data in increasing order, by the way. Plus 0.5 divided by sample size n, all times 100%. So if you have 6 children in a class, 3rd grade, and their weights are in increasing order, suppose your child is the child that weighs 92 pounds. What's the percentile rank for that child that weighs 92 pounds? So there are 4 students that weigh less than your child. So 4 plus a half divided by 6 is 4.5 divided by 6, which is 75%. So your child falls at the 75th percentile. So 75% of all the other children weigh less than your child, and 25% of the children weigh more than your child. So 75% below, 25% above. Now, reverse situation. It is possible to find a data value x that corresponds to a given percentile. So if you know the percentile, you may want to find x. And that formula is the locator formula, n times p over 100, which is equal to c. So if we have 6 children are weighed in Mrs. Johnson's 3rd grade class, find the data value x that corresponds to the 25th percentile. So you put your data in increasing order, and P sub 25 is saying that we want to find the data value, or the child the weight of the child that falls at the 25th percentile, we would say 6 times 25 divided by 100, and that's 1.5. If C is not a whole number, always go to the nearest whole number regardless of decimal and go to that member. So go to the second child that weighs 82 pounds, so that child falls at the 25th percentile. So P sub 25 is 82 pounds. Okay? And then again, if you want to find the child whose weight falls at the 50th percentile, then that is 6 times 50 over 100. Now, since it is a whole number, you would go to the third child and the fourth child, and just like you found the median, by the way, the 50th percentile is the median, you would average the 86 pounds and the 88 pounds together, and you would get 87 pounds would be the child that falls at the 50th percentile. So the 50th percentile is a measurement of position, but it's also the median of a data set. So this is where C turned out to be a whole number. Deciles are percentiles that divide a data set into 10 parts, and you have these 9 deciles, and each little subdivision is 10%. So if a value falls at the 5th decile, the 5th decile is really the 50th percentile, so I have 50% below it, and then therefore 50% above. If a data value falls at the 9th decile, then it's really the 90th percentile, so I have 90% below it, only 10% above it. So deciles are these corresponding percentiles. And by the way, the 50th percentile is the 50th decile, the 50th percentile is the 5th decile, which both of those are the median of a data set. Median. If a data value X falls at the 5th decile, I explained that again, then 50% of the data values fall below it and 50% above it, since the 5th decile is the 50th percentile, which is the median. Quartiles are percentiles that divide a data set into 4 equal parts, so there are 3 quartiles. These are given on the calculator, by the way. When you put in your raw data, your ungrouped or your grouped, and you go to calculate the data, you'll see Q1, Q2, Q3. Well, you'll see Q1 and Q3. Q2 is median. So Q1 is the 25th percentile, Q2 is the 50th percentile, which is the 5th decile, which is the median. Great true-false question, by the way. And the third quartile is the 75th percentile. So if I ask you for the data value that falls at the first quartile, it's the data value that falls at the 25th percentile. If I ask you for the data value that falls at Q2, it's the 50th percentile, the 5th decile, or the median of the data set. Okay? So those are pretty simple to find. Again, your calculator will give you the first quartile, the second quartile, which is the median, MED, and the third quartile. But if you have to calculate any other types of percentile, you'll have to do it by hand. Here's an example. The following frequency distribution table gives the number of hours students study for an exam in Mrs. Manhart's classes. She has 200 students. Find the quartiles and then the 60th percentile. I have the class boundaries in hours, and I have the frequencies. And so if I do this by hand, I need my cumulative frequency column to find all of these quartiles or the 60th percentile. I will also need the midpoint column. So the midpoint between 0 and 2 is 1 hour. 2 and 4 hours is 3. 4 and 6 is 5. 6 and 8 is 7. 8 and 10 is 9. And 10 and 12 is 11. So these midpoints represent the number of hours that my 200 students study, because I don't know the individual times. I just know my 200 students and the approximate time that they study, and that approximate time is the midpoint there. So 45 of my students out of 200 study approximately 1 hour. 10 of my students out of 200 study approximately 11. Now to find the 25th percentile, the locator, 200 times 25 over 100 is the 50th and 51st students. And you can see that they both fall here. Here's the cumulative frequency. Bring over the 45. 45 plus 55 is 100. 100 plus 38 is 138, plus 25 is 163, plus 27 is 190, plus 10 is 200. So the 50th student and the 51st student both fall here, and they both study 3 hours. So 3 plus 3 divided by 2 is 3 hours. The 50th percentile, or the second quartile, 200 times 50 over 100. I'm looking for the 100th and the 101st student. The 100, this is different. The 100th student is here. He or she studies 3 hours. But this represents students 101 through 138. So the 101st student actually studies 5 hours. That's different. So 3 plus 5 divided by 2 is 8 halves, which is 4 hours. 75th percentile, I'm looking for the 200 times 75 over 100. So the 150 and the 151st students. And they both fall here at 163 because this is students 139 through the 163rd student, and they all study 7 hours. So if you average 7 together, you get 7. And then the 60th percentile, 200 times 60 over 100 is the 120th and the 121st members or students. And they both fall here at the 138. That's student 101 through student 138, and they're both 5 hours. So that's going to be 5 hours. So I want to show you this in the calculator. In the calculator, you would go to Stat, and you would go to 4, and parentheses L1, L2, and then go to Stat and Edit. I put my midpoints of 1, 3, 5, 7, 9, and 11 hours. And then my frequencies of 45, 55, 38, 25, 27, and 10. Again, you want to check those out. And then you go to Stat, Calculate, One Variable Statistics, L1, L2. And you can see the mean and the standard deviation, but here's Q1 is 3, 25th percentile. Median is 50th percentile, or Q2, which is 4. And then Q3 is the 75th percentile, or the third quartile, which is 7. And those are the values that we found by hand using the locator formula. But it will not give you the 60th percentile, so you have to use the locator formula and the cumulative frequency formula if you want to find the 60th percentile for that. So Q1 is 3, Q2 is 4, and Q3 is 7. But for this, you have no other way to do it other than to find that cumulative frequency column, go through the locator, find your 120th, 121st student, and how long they study, and it's 5 hours if you average those together. And that's it for section 3.3. There is more practice, again, in Blackboard. And I do welcome you to practice, extra practice there. And so now at this time, you should be able to complete all of your assignments, Connect Math, your learning units, your practice test, and your sample test. And if you have questions, you can ask the class period before the test. And that also includes homework from the textbook. So I do hope you have a blessed day. I hope that you have enjoyed chapters 1 and 3. And if you need help with the calculator, just let me know. I will be glad to help you. Bye-bye.